Hello, dear friends. You are most welcome in our most popular YouTube channel Physics Make It Simple by Rajendra Kobarne from Padma Shri V.K. Patil Junior College, Pravaranagar. As long as 11 science is concerned, we are discussing a chapter Electromagnetic Waves and Communication System. This is a lecture number 3, and in this lecture we are going to discuss a topic 3.2.2 characteristics of electromagnetic waves. Okay, I have written an abstract on RHS side of the board to explain characteristics easily. The first abstract is what? I have shown electric vector, magnetic vector and direction of propagation of wave. They are perpendicular to each other. And from that, we are able to write the first characteristic, that is time varying electric field and time varying magnetic field not only perpendicular to each other, but they are also perpendicular to the direction of propagation of wave. That is the first characteristic that I have already written on the board. So what is the second characteristic? The second characteristic is prepared from this second abstract. I have written here vector E cross vector B suggests the direction and energy. So we can able to write like this. Cross product of electric field vector and magnetic field vector suggests the direction of the propagation of wave as well as the transfer of energy along with the wave. That characteristic also I have written on the board. The third characteristic I have written from this abstract. Electromagnetic wave is generated by accelerated charges. Very simple. EMW is produced by accelerated charges. That third characteristic that I have written here. Then fourth characteristics I have written from the fifth abstract. Material medium may or may not be necessary for the propagation of electromagnetic waves. So it clearly indicates that electromagnetic waves can propagate through vacuum as well as through solids, liquids and gases. This second abstract is remaining. Electric vector and magnetic vector are in the same phase. Very important characteristic. That means this is the direction of the electric vector and this is the direction of the magnetic vector. Their plane of vibration remains perpendicular like this, but their amplitude is maximum at the same time, its amplitude is minimum at the same time. That means these two vectors are in the same phase. Listen carefully again. Their plane of vibration is perpendicular to each other, no doubt, but vibration of these two particles are in the same state of vibration. So they are in the same phase. That characteristics now that we want to write on the board, student. So see here, number 3 that I will write here. Electric field vector E vector and magnetic field vector B vector are in the same phase, but their plane of vibration is perpendicular. They are vibrating in two different planes, perpendicular plane, but they are in the same phase. That is the most important thing that we have written from this abstract. Then see the sixth abstract that I have written on the board. C is equal to 1 upon square root of mu 0 epsilon 0 is equal to 3 into 10 raised to 8 meter per second. So velocity of electromagnetic waves is given by the formula C is equal to 1 upon square root of permeability and permittivity of free space. In the second lecture, I have more detail explain the concept of permittivity and permeability. See the lecture number 2. So this is the formula of velocity of electromagnetic waves, which is equal to velocity of light in vacuum or air, given by 3 into 10 raised to 8 meter per second, that I will write on the board. So here this is the sixth characteristics. Velocity of electromagnetic wave in vacuum. Velocity of electromagnetic wave in vacuum is given by C is equal to 1 upon square root of mu 0 epsilon 0 equal to 3 into 10 raised to 8, that is equal to velocity of light in vacuum. Velocity of light in vacuum. Seventh characteristic. The explanation of seventh characteristic is given by the 7 number abstract. V is equal to 1 upon mu epsilon. Mu and epsilon are the permeability and permittivity of medium. So velocity of electromagnetic wave in any medium except vacuum is given by this formula, 1 upon square root of mu epsilon. So that I will write on the board. Velocity of electromagnetic wave in any medium except vacuum is given by V is equal to 1 upon square root of mu into epsilon. Remember well, mu 0 epsilon 0, and here we have written mu epsilon. That means velocity of light in any medium except vacuum. And in the earlier characteristic, velocity of electromagnetic wave in vacuum. That is the difference. So this is the 7th number characteristic that I have written on the board. So take a screenshot at first. Take a screenshot and then remaining I will explain later on. Okay. Then we will have to discuss 8th number characteristic, but before that, let me clean the board at first. Let me clean the board. These characteristics of electromagnetic wave we can able to write very easily if we observe my lecture number 1 and lecture number 2 at first. Then it will be more beneficial to you to write the characteristics, and by making use of this abstract it will become more simplest to write characteristic. Characteristic number 8. Electromagnetic waves obey principle of superposition of wave. That is the 8th characteristic. Then characteristic number 9, see the abstract. C is equal to magnitude of electric vector, magnitude of magnetic vector, the ratio of this which is equal to constant. So velocity of the electromagnetic wave in vacuum is a ratio of magnitudes of electric and magnetic vectors, which is equal to constant. That I will write here. What is velocity of electromagnetic waves in vacuum is a ratio of magnitudes of what? Electric and magnetic vector, which is equal to constant. Then characteristic number 10. IE is the intensity of electric field, which is equal to 1/2 epsilon 0 E naught square, and IB is the intensity of magnetic field, 1/2 B naught square upon mu 0. From these two equations, what we observe? Intensity of a electromagnetic wave is directly proportional to square of its amplitude. This is the amplitude of electric vector. This is the amplitude of magnetic vector, and all terms, remaining terms are constant. So generally we can write intensity of electromagnetic waves is directly proportional to the square of the amplitude of wave. I will write what? Intensity of electromagnetic wave is directly proportional to the square of the amplitude of a wave. Square of the amplitude of a wave. Characteristics number 11. Since electric vector and magnetic vector, their plane of vibration is perpendicular, but they are in the same phase, and so that energy of electromagnetic wave is equally distributed. That is, intensity of electric field is equal to intensity of magnetic field. This is one of the most important characteristics of EMW. That I will write on the board. Energy of electromagnetic wave is equally distributed. That is, intensity of electric field is equal to intensity of magnetic field. And the last one, out of electric field vector and magnetic field vector, these are the two components of electromagnetic wave. Out of these two vectors, electric field vector is more prominent. Most important property. In electromagnetic wave, electric field vector, that is E vector, is more prominent. It is more prominent. It is more effective. So these are all characteristics that we have discussed by making use of these short abstract, and listen these characteristics very carefully. Write that all characteristics by taking a screenshot in your notebook and make alert with me. Goodbye.